In P block, it is more like a block theories, starting from
Okay.
group 13, then 14, 15, 16, up to 18. Okay.
ठीक है.
As much as JEE mains is concerned,
Hmm.
you usually have just the general properties and general reactions only. Okay.
ठीक है.
But for advanced, you would have almost everything that is there in NCERT. Okay.
Okay.
Clear?
Yes.
Now let's start with group 13, which is also called as boron family. Hmm.
ठीक है.
The elements boron has is boron, aluminium, gallium, indium, thallium. In this, aluminium is the third most abundant element in the earth crust after oxygen and silicon. Okay.
ठीक है.
The general configuration of this group being Ns2 and Np1. This
Hmm.
is the first electron which is entering into P. And generally, if you go from left to right, the size will always decrease. So if you compare
ठीक है.
lithium, beryllium, and boron, boron will have lesser in size. Okay.
Hmm.
While when you go down the group, there is an anomaly. Usually, we expect down the group the size should increase.
Yeah, it should increase. Yeah.
But here, from boron to aluminum, it is increasing, but towards gallium, it is decreasing. See,
Gallium is a metalloid.
metalloid beta, yes. It is 4s to 3d10, and then comes 4p1. So 3d10 is just being completed in the case of gallium.
Hmm.
And because d orbital electrons will have a very poor shielding on
Poor
the
shading
outermost
effect.
electrons, the size of the atom shrinks.
ठीक है.
That's why gallium is smaller in size. So this is one important exception you need to remember. At the same
ठीक है.
time, indium and thallium also are very comparable sizes. Unlike it is supposed to increase, regularly,
Hmm.
but there is not a very regular increase in the case of
ठीक है.
thallium. Again, this also accounts for the fact that in the case of thallium, 4f is completely filled. Okay, which
Yes,
is
sir.
also poor screening of 4f electrons, by which size will decrease.
ठीक
Okay,
है. ठीक है.
but once you remove the all three electrons here, just a second. Right, see, once we have
Mm-hmm.
all three electrons been removed, then the size would be a regular increase down the group. Okay, that often
ठीक है.
happens
Okay.
because the size influence will only happen on the last electrons. But now, since there is no last p orbital or s orbital, now the size will be in a very regular fashion.
समझ sir.
Density down the group increases. Okay, which is a
Yes, sir.
regular trend which you will notice. Next, melting point usually decreases from boron to gallium, and then it increases towards, you know, thallium from there. Okay.
हाँ ठीक है.
Hmm. Now, boron has the highest melting point, which is 2453, because of its three-dimensional geometry here, correct? Which is of B12
Icoso
icosahedron structure. Icosahedron
ठीक है.
usually has 12 corners and 20 faces.
20 faces.
Okay, beta.
Yes, sir.
Boron holds very strong covalent bonds with each other, just like in diamond, how it happens in diamond. Okay. Hmm.
Yes, sir.
Next, when it comes to low melting point of gallium, it accounts for the fact that gallium, the outermost electron, will try to combine with the other gallium atom and makes a covalent character and gives you something like a Ga2 molecule form. Okay.
Okay.
Now, between two
Yes.
molecules, the van der Waal interactions are very weak. Okay.
Yeah.
And because of this weak van der Waal interactions only, the gallium shows, very uh, poor or less melting point.
Right.
But one thing is, we need to observe that between melting point and boiling point, there is a huge difference. Okay,
Hmm. Yes, sir.
melting point is hardly at around 310 kelvins, and boiling
Hmm.
point is around 2676 kelvin. So you can see there is a huge gap between them. Okay.
Hmm.
Now this accounts for a larger density and higher mass when it comes to
ठीक
boiling
है.
point. Okay,
Okay.
and generally group 13's boiling point trend will always decrease down the group. Clear,
ठीक
beta?
है.
So this is the
Yes,
order
sir.
in which it will go. Clear?
बोरॉन अल्यूमिनियम गैलियम था. ठीक है.
Clear? Right.
समझ गया.
Now let's talk about ionization energy. Okay. Usually, if you compare group wise left to right, you know that beryllium will hold higher ionization than boron.
Right.
It is an abnormal trend. This is the reason being, in beryllium you already have Ns2, while boron
Hmm.
has Ns2 and Np1. Removing
Correct.
an electron from p orbital is relatively more easy than s orbital.
Yes,
Okay, so you
orbital.
can see s orbital having more penetrating power, it would be more closer to the nucleus. That's why
समझ
difficult
गया.
to remove the electron from there.
Yes, sir.
Is that making sense?
Yes, sir.
Right. Right. Next. Next, you can see second ionization and third ionization is very high for group 13 elements. Okay. So
Hmm.
if you have beryllium boron plus and beryllium plus, if you compare these two, boron plus will have
Right.
higher second ionization, and same goes with aluminum and magnesium.
Available magnesium.
Okay. So usually when it comes to first ionization, you can see aluminum and gallium will have almost the same value, with gallium being slightly greater than aluminum.
ठीक
Okay.
है. Yes, sir.
But when it comes to second and third ionization, gallium will always have higher value.
समझ गया.
Hmm. So overall, this is very uh, commonly asked trend, that is first ionization of group 13, which includes boron, thallium, gallium, aluminum, and indium. Okay.
Okay.
Earlier, one of the PYQs, it was given as a statement that gallium and aluminum shows almost the same ionization, so which is
हाँ.
correct. So there is no problem
Okay.
there. Okay.
Yes, sir.
Hmm. Clear?
Yes, sir.
Right. Next, when it comes to inert pair effect, inert pair effect is the reluctancy of these Ns2 electrons, okay,
Hmm.
which will be not participating in bonding due to the weak intervening of D and F electrons. Okay, so you can
Weak
see,
intervening.
strong intervening of this D and F electrons, which is
Okay.
4f14 and 5d10. Got it?
हाँ.
Because of these two, the nuclear charge has raised, because as many electrons you have added, the same number of protons you need to add. Hmm?
Hmm.
But that makes this 6s electrons to be much closer to the nucleus now, due to its strong
Hmm.
Z value or Z effective value. Hmm?
Hmm.
And that's the reason why it becomes difficult to remove the electrons from 6s orbital. Okay, that's
Hmm.
why thallium will tend to lose only one electron in most of the cases as compared to that of three electrons.
Hmm.
So when it comes to its oxidation state, it would like to be more stable in +1 as compared to that of
Then in
+3
plus
oxidation
two.
state. Clear?
Yes, sir.
You can see that. Boron, aluminum exhibit +3. Gallium, indium, and thallium exhibit both +1 and +3. +3 stability decreases down the group, and +1 stability increases down the group. Okay, beta?
Yes, sir.
And you can clearly see that thallium is greater than indium, greater than gallium. Right?
Yes, sir.
And you see, thallium plus has more compounds than thallium +3. Okay. In fact, you can see TLI and TLI3. Here, this will have +1 charge. This will also, this is supposed to be +3, but that is not how
Huh.
it exists. TLI3 means it exists this way. TL +1 and I3 minus.
है
This is not how it exists. Okay.
ठीक है ओके
Hmm. In fact, TL2O is also more stable compared to that of TL2O3. Okay,
टीयर टू
beta.
ओ थ्री में it exists as
+3 only, but it is less stable. Okay.
समझ
That
रहा
means
ठीक है
it'll act like a strong oxidizing agent. Try to get back to +1.
ठीक है
Correct? Hmm.
यस सर
Now, when it comes to electronegativity, from boron, then thallium, indium, gallium, and aluminum. This is the order in which the electronegativity changes.
राइट
You can see for boron to aluminum, Z effective is less, because of which the electronegativity is decreasing. But from gallium towards thallium, Z effective is more, so its electronegativity is increasing. Okay.
राइट ओके
Hmm. When it comes to reducing character, that means ability to give away electrons, aluminum has the most, which accounts for this lower electronegativity also.
हाँ
So, metal will lose out its electrons more easily to convert into M+3 aqueous form. Delta H of sublimation, you know that how do we check out the reducing character? You check out these energy parameters, which is delta H of sublimation, ionization, and hydration. Okay.
यस
If the
सर
sum of these three is mostly negative, okay, which means the hydration
यस
part is
सर
extremely dominant over ionization and sublimation, that means its reducing ability is more. Okay. It can easily oxidize. Clear?
यस सर
Hmm. Now, gallium plus, on the other hand, if you add it to water, it will undergo disproportionation. So, +1 will
ओके
undergo reduction towards gallium as well as oxidation towards +3. Same
एक
happens with
सेकंड
indium.
हाइड्रोजन कहाँ से आ गया
क्या बेटा?
where you had
No.
you had what
If
in
you
the water
had in aqueous solution, if you have X, that Ga+3 exists as a halogenated form. Okay.
so,
Hmm.
where did the hydrogen come from
NaX लिया ना बेटा? I added salt
oh
water.
that's NaX I thought it was MaX max
No, 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 no.
अच्छा ठीक है ठीक
NaX.
है
Okay.
ठीक है ठीक है
Even if you have Ga2X4 compound given, it's actually existing as Ga plus and GaX4 minus. One is at +1 oxidation state, other gallium is at +3 oxidation state.
right
Got it? Hmm. Next. Whatever we studied, these are all the general properties. As much as
ठीक है
mains is concerned, this is what you need to know. Okay.
oh okay that's it okay
Thereafter, now when it comes to reactions of group 13, we usually see reactions, how they behave in air, water, with hydrogen, with halogens, okay, and then specific reactions. Clear?
ठीक है
Starting with air. In air, we have oxygen and nitrogen. So boron, when it combines with oxygen, it becomes B2O3. B2O3 is amphoterous, acidic in nature. Although only boron is amorphous here. This boron, what it reacts is amorphous form, which means a powdered form.
समझ गया
Okay. If it is a
ठीक है
crystal form, ये easily react नहीं होता है. Okay. That means
ठीक है
icosahedron does not react easily. It has to be more of an amorphous form.
ठीक है
Aluminium, when combines with oxygen, forms Al2O3. When Al2O3 is forming, huge amount of energy is released. Okay.
okay
But there is a problem here. When Al2O3 forms, along with releasing such small high amount of energy, it will
हाँ
mostly melt the surface of the metal and converts everything into an oxide layer. Okay.
ठीक है.
So what happens is this Al2O3 will cover the entire surface of the aluminium. So now again
हम्म.
the next set of oxygen will not come in contact with aluminium.
समझ गया.
So that's how it becomes a passive form. So overall, yes, there is a reaction happens, but after some time it will immediately stops. Okay.
Immediately stop.
While gallium indium forms stable oxides, thallium forms an oxide layer as well, just like aluminium.
समझ गया.
Okay. Now boron with nitrogen forms boron nitride, aluminium forms nitride, while gallium indium thallium does not have
Does
thermally
not.
stable nitrides. Okay. So that means if we compare their bond
Okay.
energy with nitrogen, that is not as strong as that of N2.
Into,
Okay?
हाँ.
Because while you need to make this reaction, the N2 bond need to be broken. N2 is a very, very strong bond. Hmm?
ठीक है.
Yeah, beta, that only observed between boron and aluminum. Okay.
Yes.
This is with air. Now, how
हम्म.
does these group elements react with water? See, boron in
Okay.
a crystalline form does not make any reaction even with a hot water or a steam. But once
ठीक
it
है.
becomes amorphous, probably you make it into powdered form, then it will react with steam and forms B2O3 and releases H2 gas. Okay. But see, as per
Okay.
NCRT, it is mentioned that boron is unreactive, maybe taking with the fact that crystal is not reacting. Okay.
ठीक है.
So aluminium, on the other hand, with cold water, there is no reaction. But with steam, it will become Al2O3. Again, Al2O3 will form a passive layer.
ठीक
Got
है.
it? Next, check out how boron behaves in various acids. If you add it
Yes.
with dilute HCl, dilute H2SO4, dilute H3PO4, because these acids are non-oxidizing in dilute conditions, no reaction will take place. But
Yes.
only when you take concentrated H2SO4, boron will convert into boric acid and SO2, and concentrated HNO3 also boric acid and NO2.
Yes.
On the other hand, aluminium dissolves more easily better. Aluminium can dissolve even with dilute HCl, converts
ठीक
into
है.
Al2Cl6 and H2 gas. Okay. Even with H2SO4,
Dimer.
same sulfate and H2. Hmm? Well,
Dimer.
first it forms AlCl3, but AlCl3 will dimerize to form AlCl6. Hmm?
82CI6. ठीक है.
Hmm. And with concentrated H2SO4, instead of only giving H2, now it will become sulfate and gives away SO2. So now there is an oxidation reaction happening.
हाँ ठीक
Because
है.
H2SO4 now acts like an oxidizing agent. Okay.
ठीक है. ठीक. Got it.
Similarly, when you react with HNO3, dilute form, you will have AlNO3 twice and ammonium nitrate. But
ठीक है.
in concentrated form, first it will form an oxide layer and further reaction
हाँ.
will be stopped. So with concentrated HNO3, aluminum does not make any reaction. But
ओके समझ गया. हाँ.
clear?
ठीक है.
Clear now?
ठीक है.
Right. Next, check out reaction with alkalis. If you react aluminium with NaOH and H2O, okay,
Oh
aluminium will
yeah,
become
this I know.
NaAlO2, got it?
हाँ, हाँ.
And NaAlO2 with H2O, it will form NaLOH4, got it?
Correct, correct, yes, I
Basically,
know.
this is called sodium meta-aluminate, releasing
Yes,
H2 gas here. But if you take
yes.
little concentrated, it will become Na3AlO3 with
हाँ.
H2O. It would appear like a octahedral complex. Here it is tetrahedral, here it is octahedral complex.
Octahedral. Sorry.
While other metals do not react with the alkalis easily. Okay. Hmm.
Yes.
Now, what about non-metals? Boron plus carbon can form B4C. That means boron and carbon will start holding a strong covalent bond. And these are called methanites. And usually,
Okay.
if they have a covalent bond, they do not give, you know, methane on hydrolysis. Got it?
How do I tell the bond is covalent?
That is based on its polarizing power. Borons, if you have plus 3, it will have extremely strong polarizing power to pull the electrons towards itself and convert into a covalent bond.
Covalent bond. ठीक है समझ
Okay.
गया.
While on the other hand, aluminium forms methanide, but that on hydrolysis will give you hydroxide and CH4, which suggests that this has more ionic character.
समझ
Okay.
गया.
While these three elements does not form any carbides. Clear?
Yes, sir.
Next. Boron also gives a borax bead test, which we have discussed in
Which
salt
we have
analysis.
discussed in qualitative
So when
analysis.
you get B2O3 and react with, let's say, copper as an example, it will become a colored beads. Okay. And it
Yes.
colors keeps different. I mean, it changes differently in different flame. Oxidizing flame, it will be different. Reducing flame, it will be different. Okay.
Yes, sir.
Right. If you compare the oxides and hydroxides, aluminum and gallium usually have
हाँ.
amphoteric nature, while indium thallium has more basic nature, while
ठीक है.
B2O3 or BOH thrice, this is acidic in nature. Okay.
ठीक है.
This is the distribution of the respective oxides and hydroxides. Okay. Now, what is the typical anomalous behavior of boron? Because of its
What?
smallest size and high charge on boron plus 3, it will have high polarizing power. That's why most of its compounds are covalent. Okay. And because of its high uh, small size, it also has very high ionization energy. It has high
ठीक है.
electronegativity. It has very high boiling point and melting point compared to the others in the group. And halides of boron exist as monomers, while AlCl3 exists as dimers. Correct? Because
Got it.
boron, when it comes to formation of BF3, BCl3, BBr3, and so on, it will have a back bonding within them. So it does not
Right.
require two different molecules to combine. Within that molecule only, it will exhibit back bonding and try to stabilize itself. Okay. Next,
Right.
it does not react with steam, and but other compounds usually react with steam. Hmm.
ठीक है.
These are typical differences. Next, there is a certain level of diagonal relationship with boron. Okay, so you can see both
Okay.
boron and silicon are non-metal. Okay, sorry, non-metal and shows metalloid character. See, as per NCRT, both are given as non-metals. Okay, clear. But suppose if
Yes,
there
sir.
is a question given where silicon is being used, silicon is always having this, uh, confusion whether we should take it as a metal or a non-metal. I mean, metal or a metalloid.
Metalloid.
Hmm. I mean, non-metal or a metalloid. So in that case, you go with the options. If there is a definitive metalloid given, you go for it. Otherwise, if all three options are observed that they are definitely not metalloids, then go for silicon. Hmm.
Yes, sir.
Both can be used as semiconductors. Both do not form ionic compounds. I mean, they do not specifically separate out as boron or silicon ions. Both forms covalent hydrides, that is B2H6 and SiH4. Okay. Both form covalent and volatile halides. So BF3, BCl3, or SiCl4. These are all covalent hydrides. Okay.
समझ गया, समझ गया.
Hmm. And they will which fume in moist air due to release of HCl vapors like this BCl and H2O. In moist air, it can become boric acid and gives the fumes of HCl. Okay.
हाँ.
And both form solid oxides which are acidic and dissolves in alkali, forming borates and silicates. So that means because this is an acidic oxide, this is an acetic oxide, they can react with base and convert into salt forms. Okay, sodium
ठीक
borate
है.
salt or sodium silicate salts. Clear, beta? This is the diagonal
Yes,
relationship.
sir.
Now, let us see individually what are the compounds we need to know from group 13. Okay. First thing we need to know is, hydrides. Within hydrides, the main hydride we need to learn is B2H6. Okay.
Hmm.
Preparation wise, you see, BF3, when you react with lithium boron hydride, lithium boron hydride is a H minus donor, correct? So this minus will come here, try to replace the fluorine, and that's how you will get, first you will get BH3, and BH3 will combine with each other to form B2H6. Okay.
हाँ.
Similarly, magnesium boride, when it reacts with H3PO3,
Hmm.
this will give you mix of boride, mix of higher boranes, correct? Because here boron has negative charge now, that will take H plus from acids and convert into mix of higher boranes. See, it is not only B2H6 beta, it can keep on combining with any ratio of hydrogens. Correct?
Right.
Clear. Mainly there are three type of hydrates or boranes which are useful. Is one is Bn2n, correct? So for every one boron, if you have 2n hydrogens, like if you have B2 and H4, B4 and
Hmm.
H8, like that. Those are called closoboranes. Okay. And BnH2n plus 1 is rarely observed. There are chances, but it is rarely observed. But
Okay.
BnH2n plus 2, this is called nidoboranes. And 2n
Nido.
plus 4, it is called arancoboranes.
Aranco bowl. So 2n is
Got it?
closer, 2n plus 2 is Nido, and 2n plus 4 is
Aranco.
ठीक है. Aranco.
Hmm. Now B2H6 is what beta? Okay. This is 2n plus 2, correct? So it is a nidoborane. Hmm.
Nido bowl.
So nidoborane is very, very common form. Clear? Hmm. Now notice BF3, when you react with sodium hydride, it will again release fluorine, replacing that with hydrogen. So we'll get B2H6 here as well. Clear?
Yeah.
Okay. Next, if it comes to NaBH4, okay, this is boron hydride, boron H4 minus. And that when you react with H3PO4, one of the hydrogens will take H plus, converts into H2, and rest will come out as BH3, and 2 moles of that will combine together to form B2H6. Got it?
Yeah.
I hope that makes sense. Yeah.
Yes, sir.
Mm. So
Sort of.
these are ways of preparation of boron beta. Okay. Now, boranes are generally most very stable, but the stability of hydrides of aluminum, gallium, indium decreases as you go down the group. Because as you go down the group, the strength of the metal and hydrogen bond decreases due to size. And if you
Correct.
notice the bond dissociation energy, obviously here the overlapping is between 2p and 1s, which is a stronger overlap compared to 3p 1s, 4p 1s, 5p 1s, and 6p 1s. Okay.
Right.
And when it comes to diborane, diborane is a colorless gas. It is an electron deficient molecule because its octet is
Diagonal.
yet not completed. Okay.
Huh.
It is highly reactive
Yeah.
and catches fire in air. Okay.
Okay.
This one is specifically used because it will, release a lot amount of energy as compared to how much amount of fire it catches. It is not like a regular combustion reaction. Okay. So B2H6, just as it comes in contact with air or oxygen in air, it will immediately become B2O3 and H2O is being formed. So this H2O will avoid lot of fire formation. Okay. So it will come out as steam, and but huge amount of energy is released. You can see that. Yeah.
Yes, sir.
Next. B2H6, usually when it comes to chemical reactions, right, it can make two types of reactions, beta. One, it can make a similar symmetrical cleavage so that BH3 gets separated, or
Hmm.
reagents can make it unsymmetrical cleavage where this will become BH2 plus and BH4 minus. Okay, so two
ठीक
types
है.
of reactions are usually observed. One is a symmetrical cleavage observed or an unsymmetrical cleavage observed. Okay, now if at all we are reacting with a small size basis or at least strong basis, the element from where it is connecting, right, that element
Right.
is smaller in size, which is having a lone pair. Okay, then
Hmm.
usually it will always go for unsymmetrical cleavage. Like ammonia,
Right.
nitrogen is a smaller atom carrying lone pair. Here also lone pair, here also lone pair. Then
हाँ.
fluorine, hydrogen, OH, these are all small in size. So two
Right.
criteria you need to check. Either it should be strong
Small.
or it should be very small in size. Hmm?
Right. Hmm.
In that case, unsymmetrical cleavage is the most favorable form. Okay.
समझ
But
समझ.
if you have a weak or bulky base, okay, either it has to be
ओके.
weak, carbon monoxide, very, very weak base. Hmm? Or
हाँ.
you can see pyridine, although nitrogen is smaller because it is in a cyclic structure, it is bulkier now. Okay.
हाँ.
Trimethyl amine, very bulkier. Oxygen in a cyclic structure, bulkier. Okay. Uh, Phosphorus in general is bigger in size, sulfur is bigger in size. So therefore,
हम्म.
if you have these molecules trying to attract B2H6, we can
Right.
expect them to go for uh, symmetrical cleavage. Clear?
Yes, sir.
I guess that makes sense.
Yes, sir.
Now notice when it comes to B2H6 and when you combine with carbon monoxide, the lone pair from here will connect onto boron. You will get 2 moles of this compound. Okay. Now this is something which we learned in chemical bonding, that the bond order of carbon monoxide is 3. Hmm? But the bond order of carbon monoxide with a plus charge is actually greater than 3.
Greater, yeah, it's 3.5.
And because it is donating electrons towards boron, the bond order between carbon and oxygen actually increases and it will come close to 3.5. Clear?
Yes, sir.
Next one. The lone pair on nitrogen attacks here. You can get 2 moles of BH3 here. Same way,
Hmm.
sulfur attacks here. You can get 2 moles of this. Now, H minus attacks. H minus is what, beta? H minus is a very smaller base and stronger base.
Right.
So this will give an unsymmetrical cleavage. Okay. So you can imagine like this: BH2 2 plus and BH4 minus, correct? And now
VH2
two
2 plus.
hydrogens will combine here. So that makes it 2 moles of BH4 minus. One BH4 minus is already formed and two more H minus will go and connect here. So makes it into LiBH4.
हाँ, ठीक है.
Make sense?
Yes, sir.
Right. If lithium, sodium, or potassium is connected with, boron hydride, lithium, because of its high polarizing power, will make a strong, it will have more thermal stability compared to sodium, compared to potassium. Okay. And also, you need to understand that lithium can
Hmm.
easily club. Let's say if you have C double bond O here and you're treating with lithium plus BH4 minus. Okay.
Lithium plus
So the
BH.
oxygen from oxygen's lone pair can connect very strongly with lithium as compared to sodium or potassium. And
Hmm.
that gives a chance for BH4 minus to attack onto this carbon. Okay. That's why lithium will make a better reducing nature compared to NaBH4 than KBH4.
KBH4.
This we learned
Okay.
in organic that when it comes to NaBH4, it is a good reducing agent,
But
but lithium
NiBH4 is
boron hydride
better.
will become a better reducing agent. Okay,
Yes, sir. This we have done, so.
correct. Next, Other form of reactions is when you have B2H6 added to water, right? So here boron and hydrogen, if you compare the electronegativity, hydrogen has more electronegative nature. So that H minus will take H plus from water, converts into H2, and the remaining OH minus will combine with boron, converts into boric acid. Okay. And
Hmm.
even when you add alcohols, also the same thing will happen. H2 will go and alkoxy boron will form. Okay. Even if you take 1 mole of HCl also, you will see you will get B2H5Cl and H2 will be released. If you have water in the presence of base, that means it is aqueous, it is dilute, basic nature. In that case, first तो ये बनेगा बेटा, boric acid and H2. And boric acid is an acidic group, so that acid will react with the base, convert into the salt form.
Hmm.
Clear? And
Yes, sir.
lastly, if you have 6 moles of chlorine, this Cl, this H minus will take Cl plus, converts into HCl. And that Cl minus part will connect onto boron, convert into BCl3. Okay. So
Yes, sir.
give it a quick browse of these reactions once, then we'll go ahead. Please check once properly.
ठीक है, एक सेकंड.
Now notice the structure of diborane. B2H6
Hmm.
actually makes an sp3 hybridized boron. Here, two hydrogen bonds here and two hydrogen bonds here are a simple covalent bond. That means one electron is shared by hydrogen, one electron is shared by boron.
Boron. Hmm.
So these are called as two-centered two electron bonds. Okay, and there are
Yeah.
four such kind, and these are called basic simple covalent bonds. Okay, but
Okay.
then there is a boron here which is bonding with this hydrogen, but in this case there is only one electron which is being shared with hydrogen. Between
Okay.
boron and hydrogen only one electron is being shared. Clear? And between this hydrogen and boron only one electron is being shared. Clear? So between
Yes,
these two
sir.
one electron is being shared. So if you compare this
समझ सर.
boron, hydrogen and boron together,
Hmm.
this in this case, both these electrons are moving between these three places. Okay.
Right.
So because of which these two electrons are moving between boron and hydrogen here, and that's how it will make a shape of an uh, banana. Got it? The cloud looks like a banana cloud. Okay. So these are
Yes,
called
sir.
1, 2, 3, three-centered, and only two electrons are present on it. So that's why it is called
3C2.
three-centered two electron bond, also known as banana bonds. Okay.
Yes, sir.
So you can see two such bonds are present here. Okay.
Hmm.
And because there are two bonds here and two bonds here, that makes it as a tetrahedral structure and hence making it as sp3 hybridized orbital.
Um,
Clear?
समझ सर. सर,
Yes, beta.
समझ सर. ठीक है, ओके. समझ सर.
Now, obviously here, because you have two electrons sharing, the bond length will be smaller, energy will be higher.
Yes,
That's
sir.
why if you notice the bond length, that is 119 picometers. But here there is only one electron sharing. That's why the bond length will be longer, which is 134 picometers, and bond energy will be lesser. So given the fact when bond has to break, this is the first bond that will break more easily, boron and hydrogen bond.
Hmm.
Clear?
Yes, sir.
Right. Next. See, diborane on methylation will give you B2H2 Me4. See, methyls cannot fit in the center beta. Okay. So when it comes
Hmm.
to methylation, that means if you have something like CH3 group on it, correct. So this hydrogens can be
Right.
replaced by methyl at this corner positions, not at the center. Okay. So they will only replace this terminal positions. Understood?
ठीक है.
Hmm. Next one, B2H6 when you react with ammonia, and you know that ammonia will make an unsymmetrical cleavage. And this is
Hmm.
what you will notice, unsymmetrical cleavage is BH2 plus 2 and BH4 minus. Okay, BH2 plus and BH4 minus. And 2 moles of nitrogen will combine here, making this entire group as plus and this group as minus. Okay,
Yes,
so
sir.
it exists like a complex here. But the minute you heat it around 200 degrees centigrade, this would release H2 gas and convert into a compound which is called as inorganic benzene or borazole. Okay,
Inorganic benzene.
why it is called inorganic benzene? See, it is exactly like benzene, except instead of all carbons, now you have 3 borons and 3 nitrogens.
Three bonds. Hmm.
Clear?
समझ गया. Yes, sir.
Any doubt?
No, sir, not really.
See, benzene ring will show higher resonance energy due to non-polar charges. Okay. Reason being,
Right.
in the case of benzene, between carbons there is no charge existing, right? There is no electronegative
हाँ.
difference. But here there is electronegative difference. So nitrogen tries to hold positive charge. I mean, because it has positive charge, it tries to hold electron at a most of the time. That means the movement of these electrons is quite weaker. So that means the resonance would happen much slowly, isn't it?
ठीक है.
So that's why you notice that the resonance energy of benzene is, quite high compared to that of borazole. Okay.
Yes, sir.
Correct. Next. Instead, see, if you do not want to use directly with this reaction, so what you can do, if you heat it at a high temperature, correct, with excess amount of
Yes, sir.
ammonia, then all of the hydrogen will release as H2 gas, and nitrogen will combine with boron and convert into a BNX, a polymer form which will similarly look like graphite, or what we call it as inorganic graphite. Okay, just like graphite
Inorganic.
structure. Graphite, how would that be? But again, it will be having this carbon
Carbon
carbon bonds
carbon
all together like
layers.
this, with all of them having three bonds. Okay,
Layering
so
types.
just imagine alternatively we have boron and nitrogen. Hmm?
Nitrogen.
Hmm.
ठीक है. Yes, sir.
This is a very standard and most asked reaction for advanced, wherein if you know the inorganic benzene is also being prepared by using ammonium chloride with BCl3. So that means not directly using B2H6. We are using BCl3 reacting with ammonium chloride. Okay. On doing this
Okay.
at around 150 degrees, clear, you would
Yes,
see that
sir.
3 moles of this will become B3N3H3 and Cl3.
B3 and 3 H3 and Cl3.
Correct.
Yes,
So
sir.
which means it is same as inorganic benzene. At 3 position we'll have hydrogens. At 3
Hmm.
positions we'll have chlorines. Okay. Got it? You can see the
Yes,
mechanism
sir.
here. See how it forms. Notice this. First mole of nitrogen attacks, Cl minus has left, correct? So you will get this
Yes,
form
sir.
with HCl being vaporizing. Okay. Imagine like this 3 moles have already formed. Imagine 3 moles has formed. Now within 3 moles
Right.
the cyclization will take place. Nitrogen will attack one boron. This nitrogen will attack the next boron. This nitrogen will attack the next boron. That will lead to the formation of this one. Clear? Which is what I have written
In
here, B3N3, H3 and Cl3. Okay.
B3
Thereafter,
and 3 H3 Cl3.
thereafter I need to release these 3 chlorides. So H minus has been treated. You can use NaH,
Okay.
you can use NaBH4, lithium aluminum hydride, anything which can provide H minus. So this H minus will source here to remove Cl minus. And that's how you
हाँ.
will get the inorganic benzene here. Got it?
ठीक है, okay, yeah.
And what if, because boron chlorine bond is present, what if I use 3 moles of Grignard's reagent? So what will it do? R minus will come here, attack boron, remove chlorine. So you will get an R substituted inorganic benzene. Hmm?
हाँ
Clear beta?
R substituted inorganic benzene.
Hmm.
I see.
So these are typical reactions of diborane. Okay. Now, what are general points we need to know? See, borazole is isostructural and isoelectronic with benzene. Hmm? It is planar
Yes,
and
sir.
non-polar. Okay.
Yes, sir.
It is less aromatic than benzene due to electronegativity difference between boron and nitrogen. While
Yes, sir.
benzene shows electrophilic substitution, borazole
Hmm.
shows electrophilic addition.
Addition. Hmm.
Okay. Hmm. Then it can show electrophilic addition. Next,
Addition. Hmm.
borazole is more reactive than benzene. Okay, if you notice, this is borazole here. When you react with HCl, because addition is happening, you know, H plus will get added here, Cl minus will come here. Again, H plus will get added here, Cl minus will come here. Like that, you can see
Right.
3 moles getting added up. Hmm.
Hmm.
Next, borazole also undergoes a slow hydrolysis with water. So that means if this is borazole reacting with water, boron will convert into hydroxide, ammonia will come out, and H2 gas will come out here. Okay. BOH thrice is nothing but boric acid.
BOH thrice is nothing but boric. Yeah, okay. H3BO3.
Done.
Yes, sir.
Next. Next, let us see boron nitrate, which is an inorganic graphite. See,
Hmm.
amorphous form of boron directly reacts with nitrogen can give boron nitrate. Even when you react with excess of ammonia, we learned it, it will give boron nitrate. Okay. When you react B2H6 completely, you will get a complete polymeric form, and polymeric form will look like this, which will have a similar structure as
Right.
that of graphite like that. Okay.
Yes, sir.
So the alternative ways is you can use B2O3 in ammonia, borax in ammonia. They will also give you boron nitrates. Okay.
ठीक है. Hmm.
See, boron nitrate have this layered structure which is very similar to alpha graphite. Hmm? Graphite has
Right.
many forms, beta, alpha and beta graphite forms. They go alpha graphite form. We say it has an alternative structure like this, AB type of structure. Okay, correct.
AB, AB,
So
AB.
AB type is something which you learn in solid state. Ki, if you have one particular type of arrangement, then uske grooves में next arrangement बिठा रहे हो. Hmm? That is
समझ
going to
गया.
become AB type of arrangement. Okay. Hmm. Clear? While boron nitrate will not be like that, it will be more like an AA type of arrangement. Okay.
Yes, sir.
Next,
Yeah.
the interlayer distance between boron and nitrogen is slightly lesser than graphite. See, this is called interlayer distance. Okay. In the case of graphite, what happens? This length is longer because इसमें कोई polarity नहीं है. But when
Yes,
it
sir.
comes to boron nitrate, imagine यहाँ पर boron है, यहाँ पे nitrogen है. So it will be an attractive force, correct?
Hmm.
That will
Correct.
make that length smaller. Okay. Hmm.
Yes, sir.
Next, due to weak van der Waals forces of attraction, boron nitride and graphite are lubricants. Correct. And alpha
Yes,
graphite
sir.
is a better lubricant here. Clear?
Right.
Hmm. And unlike graphite, boron nitrate is white and it is insulator. It will act like an insulator. Okay. Because there is no extra electron like in graphite which is moving around within the layer. Okay. Hmm.
Right.
And unlike graphite, boron nitrate does not react with air even at high temperature. Hence, it is used as a refractory material. That means
Yes, sir.
refractory material is something which will hold a very high temperature. We studied that in metallurgy. Hmm.
समझ गया.
So if you have Bn, which is hexagonal, even at 2000 degrees centigrade, It can only change its shape maybe, but it does not melt or it will crack or something. Okay.
Hmm.
And they will start showing more like a diamond structure form. Okay. Hmm.
Yeah, okay.
Hmm. Now, boron nitride, when you react with steam, it will start cracking into boric acid and ammonia.
Yes, sir.
Clear, beta? Right. So,
Yes, sir. So can I just use the washroom and come?
yeah, sure, beta. One
Thank you.
second.
So may I doubt actually
Yes, beta.
before we continue?
One
Might
second.
as well ask now only.
Hmm.
Hmm.
See, when it comes to next compound, which is borax, okay,
Huh.
uh, the main ore to extract the borax is colomanite. Colomanite is calcium with B6O11 form. Okay.
Columenite.
Now, this colomanite, when you react with Na2CO3, it will
Hmm.
convert into CaCO3,
Hmm.
Na2B4O7, and NaBO2.
Hmm.
And this NaB4O7, when you treat with NaBO2, right? I mean,
Hmm.
we take this basically ये crystallize बनेगा, ये liquid रहेगा. So उसको लेकर आप crystallize करोगे. Okay. Then it will become a crystal which appears like this Na2B4O7.10H2O. Okay. Now notice one thing here.
Hmm.
This borax crystalline form will have two borons with three bonds. Okay. And one
Two
with OH
borons
and
with
OH,
three
the other two with
bonds.
oxygen and oxygen. Okay.
ठीक है. Hmm.
And then you will have two borons with four bonds, three with oxygen bonds and one with OH bond. Okay.
ठीक है.
And obviously it has an extra bond, so that makes it negative charge and negative charge. And that total negative charge is balanced by Na2 plus. Hmm.
Hmm.
And apart of that, there are eight more water of crystallization observed on this molecule. Okay.
Yes, sir.
So which means out of this 10 water molecules as it is written, two are actually
Hmm.
present within the molecule only, and eight are present as the water of crystallization. Okay.
Crystallization. Yes, sir.
So this is one thing you need to remember. There are five BOB bonds and two sp3 hybridized borons and two sp2 hybridized
sp2
borons.
hybridized borons.
Clear, beta?
ठीक है. Hmm.
Borax, when you hydrolyze with a larger quantity of water, it will start converting itself into boric acid and conjugate base salt. Okay, as I samjho, water is attacking here, correct? Water is attacking
हाँ.
here, isn't it?
Right.
So this part of the water will become BOH4 minus, and this part of the boron will become BOH thrice.
Thrice.
So there will be 2
Hmm.
moles of boric acid and there will be 2 moles of conjugate base salt. Hmm?
समझ गया, समझ गया. Hmm.
अच्छा, आपके पास एसिड है और उसका conjugate salt है, तो what do we call it? Buffer ना बेटा. So what are we getting? An acidic buffer.
Hmm.
So borax in aqueous solution is an acidic buffer. Okay.
Okay.
And since while hydrolysis, you will notice that the acid quantity and the salt quantity is equal. So ये तो cancel हो जाएगा formula में. So pH will be equal to pK and pK value of boric acid is 9.26. Hmm?
Hmm.
So it is a acidic buffer having slightly basic character because the pH value is 9.26. Okay.
Right.
And moreover, if at all I add water along with HCl, ये जितना भी base बना था, conjugate base, that will react and again convert back into boric acid. Okay. So this time you'll have 4
Right.
moles of boric acid and NaCl. Okay.
Hmm.
Usually, borax is used as a primary standard just like others. What are others?
Right.
Oxalic acid, HiO3, Mohr salt, AgNO3, K2Cr2O7. These are solutions which are used as primary standard. Primary
Right.
standard are those solutions which are completely inert to atmosphere. Their concentration remains constant for a very long time. They do not undergo any decomposition in air, water, or in light. Okay.
Hmm.
And borax is one of them. Okay. Hmm.
Hmm.
Next, borax goes through a borax bead test, which we learned it already. There is a glassy bead form. Copper wala is the most important example which we'll be using. CuO react with B2O3. First, it will become cupric borate. Okay, cupric borate is what you will observe in the oxidizing flame. And in the oxidizing flame, when it is hot, it will appear green. In cold, it will appear blue. And when you bring it to the reducing flame, you will have a carbon soot, which will further reduce the copper into Cu. And the Cu part, when it is in hot part, when it is hot, appears colorless, and when it is cold, it appears red color. That's what you will notice in reducing flame. Okay. So this is in oxidizing flame, this is in reducing flame. And these are the compounds which are from borax bead test, just to revise you immediately. I mean, from salt analysis. Immediately, if you want to revise, just check it out. Copper 2 plus reducing flame. Usually, always check out what is the color when it is cold. Okay. So when it is cold, red. When it is cold, blue. Chromium, it is always green. Cobalt, it is blue. Iron, green and yellow. Manganese, colorless and violet. Nickel, gray and brown. Okay. So these are the colors we need. Next one, one more important compound of boron is orthoboric acid. Now, BX3, when you react with water, it converts into boric acid and HX. And B3N3H6, that is inorganic acid, inorganic benzene, when you react with water, also becomes boric acid, ammonia, and H2. Borax also we just learned, when you react with H2O and HCl, will convert into 4 moles of boric acid. Boron nitride also, when you react with steam, it will convert into boric acid. See, boric acid has something important, the structure wise. Actually, मैंने पहले structure लिखा था, but this is a wrong structure. I'll just remove this part. Okay, 1 second. Yeah, this is typically how the boric acid looks like. Correct, single one molecule. But the minute when you have it in a hydrogen bonding form, because ये sp2 car sp2 boron है. So around it, these are all planar. Okay. So now hydrogen will also exist on the same plane and start showing a hydrogen bonding like this. Okay. Now notice what is a hydrogen bonding for every molecule. See, boron is making hydrogen bonding here with the next molecule of boric acid. Here also next molecule of boric acid making hydrogen bonding. So in a way, one boric acid, boric acids are making a 8-membered ring, if you notice, correct? So 1, 2, 3, 4, 5, 6, 7, 8. So they are making an 8-membered ring. Okay. So you will see not 6-membered, but an 8-membered ring forming across hydrogen bondings. Okay. Next, these molecules will be two-dimensional sheet due to intermolecular hydrogen bonding, and it also makes it extremely smooth on the surface because of its planar structure. Okay. Boric acid is very sparingly soluble in cold water and soluble in hot water. It is weak monobasic acid, acts as a Lewis acid and not a Bronsted-Lowry acid, which means it is not going to give H plus, but instead it will accept OH minus. So when you add boric acid to water, it will accept OH minus and increases the H plus concentration. That's how it will act like an indirect acid. Okay. pK value, we learned it as 9.26. But in hot conditions, right? If you take warm water or hot water, in that case, now instead of converting into this salt form, it will convert into the cyclic structure form. Okay. BOB, BOB and BOB bonds here with one boron accepting one OH minus and then giving H plus. So what happens here is 3 moles of boric acid is releasing H plus. Now this time the pK value is less, which means the acidic strength increases, acidic character increases. Okay. Then now this is generally asked only in advance. Check out. Of course, now everything is in advance only. Earlier it used to be only for advance. Titration of boric acid. Boric acid, when you react with NaOH, you know, As we make any acid-base reaction, we expect a sharp endpoint, correct? Sharp endpoint means we will be able to see sudden change in the color, okay? So that we can stop it, stop the titration. But problem here, what happens is, imagine these two are acid-base reactions. You'll form salt and water. But this salt easily hydrolyzes and comes back, correct? So पता भी नहीं चलेगा कि यहाँ पर acid खत्म हुआ है कि नहीं, okay? So the reversibility is very
Right.
strong here, correct?
Hmm.
So immediate hydrolysis will keep happening here. So to make sure you get a sharp endpoint so that we can get an instant color change there, you need to stop this reversibility. And this reversibility can be
Right.
stopped when you try to stabilize this complex. Okay. To stabilize this complex, we use a polyhydroxy compounds, and keep it in the solution right from the start, like glycol, glycerol, sorbitol, mannitol, cis 1,2-diol. When you have this group, what happens? As it forms BOH4 minus, immediately those compounds which are present in the solution, they make a hydrogen bonding and convert into a chelated form here. See, okay, you remove
Hmm.
this water molecule first and make it into a chelated complex. Okay,
Okay.
because of the cyclic complex here, this and it is being more stable now. It does not undergo hydrolysis and make a reaction to go backwards anymore. Clear?
Hmm.
So important point is there should be cis 1,2-diol, and these are all cis 1,2-diols. Okay. Adi clear beta.
Hmm.
Now next reaction is, that boric acid, when you react with alcohol, just like acid and alcohol reaction makes an ester, here also you'll get an ester, and the ester name is trialkoxyborane. Hmm? Okay.
Hmm.
Trialkoxyborane is volatile because boric acid में hydrogen bonding था. Here there is no hydrogen bonding, so that makes it more volatile. Hmm? And
Hmm.
especially if you have methyl and ethyl, volatility is more. And when you bring it to the flame, it will start burning like a green edge flame. Okay.
Okay.
That green edge flame represents that there must be a boron present. Okay. So
Hmm.
this is used as the uh, test for identification of boron. Okay.
Right.
The last thing is about sodium peroxoborate. It is used as a brightener in washing powder. Got it? Okay.
Okay.
It is like a mild a peroxy oxidation. Okay.
Hmm.
So kind of a bleach. Okay. Mm. It is prepared by NaBO2 with H2O2. So you take sodium metaborate, react with H2O2. Then that
Okay.
H2O2 will, start surrounding with borons and convert into a complex like this. This is the complex which it forms. So between two borons, we'll have OO bond like this. Okay.
Hmm. Hmm.
So this is sodium peroxoborate formation. देख लिया बेटा.
Yes, sir.
Last thing is about extraction of boron. So boron can be extracted either from borax, kernite, columnite. Kernite is with less number of water molecules. That's it. Okay.
Hmm.
Columnite, we have learned it, calcium boron form. See, uh, first, if you want to prepare B2O3, okay, so I'm going step by step so that B2O3 can further convert it into boron. You
Hmm.
take boric acid, heat it around 100 degrees. First water molecule will be lost. Now, if you have only one hydrogen, it is
Okay.
called metaboric acid. Hmm?
Yeah.
And the metaboric acid is heated again. So you take 4 moles and remove water again. So you will have
Hmm.
H2B4O7. That is called pyroboric acid. Hmm?
Right.
And finally, when you heat further with the pyroboric acid, it will convert into 2 moles of B2O3. Okay.
Oh, God. Okay.
So, ये uh, heating method important. Okay. How you get B2O3. Hmm.
Okay.
Now, B2O3 can be reduce to boron easily taking any strong reducing metals like sodium, potassium, magnesium, or aluminum. If you take sodium, potassium, magnesium, we usually get an amorphous form. If it is aluminum, we'll get a crystalline form. Again, this distinction is not usually asked in JEE, so don't worry about it. Okay.
ठीक है.
So you just need some metals to reduce it. Now, another method is you take boron iodide, okay,
हाँ.
and then react that with tungsten, okay, or titanium or tungsten. So what happens? And heat it strongly. So boron will get separated, I2 will get separated. So this way you will have pure boron forming. It is called Van Arkel's process.
Hmm.
Okay. Hmm.
Yes, sir.
Now you know this. Thallium, when it is with iodide, I told you that it will exist as Tl plus and I3 minus, correct? Hmm.
Yes, sir.
Now, if you have boric anhydride B2O3 and treat with X2 in the presence of carbon, carbon will take away oxygen into carbon monoxide gas, and boron will convert into BX3. Hmm?
Hmm.
And this is how typically haloborides, boron halides are being prepared. And now for
Okay.
fluoride specifically, you take calcium fluoride, react with B2O3 in acidic medium, you'll get BF3. Now,
Hmm.
BF3 is a gas, these two are liquids, and Bi3 is solid. Okay. And remember one thing here, in the case of BF3, you will have 2p2p overlapping. Okay, why is that? See, boron has an empty orbital and fluorine has
Okay.
lone pairs on it, correct?
Hmm.
So this lone pair will support boron, gives a partial double bond character, and that's how it will support as a back bonding. Same happens with BCl3, same happens with BBr3, and same happens with Bi3. Hmm?
Hmm.
Out of this, here the bonding is weaker, right? Because it is 2p, 5p. Which means because the back bonding is weaker, the borons still have high ability to accept the pair of electrons from outside. Hence, Bi3 is a stronger acid compared to BBr3, BCl3, and BF3. So you could imagine
Okay.
stronger back bonding means weaker acidic strength. Are they clear?
Okay.
Hmm.
Yes, sir.
Down the group, acidic character usually decreases because of metallic character being increasing. By the time it comes to thallium, you'll have more metallic nature. So it will not be accepting a pair of electrons easily. Hmm? Hmm.
Hmm.
Next. Other form of halides, if you notice, aluminium fluoride will be completely ionic. With chlorine, bromine, and iodine, it is covalent. Okay. Obviously, because it is ionic, it will have high melting point. Then AlCl3, AlBr3, and AlI3. Now, if you notice the
Hmm.
hydrolysis, AlCl3 will make a better hydrolysis than AlBr3, AlI3, and AlF3. See, AlF3, the lattice energy is very high. That's why its hydrolysis is weak. Okay. Even though it is ionic, its lattice energy is very high. Okay. Adi, does it make sense, beta?
Yeah. Okay.
Right. Now notice, last thing, AlCl3, how does the structure looks like? See, AlCl3 also forms a dimer, wherein
Right.
you will have four chlorides with two center, two electron bonds, and two chlorides between the two aluminiums. Okay. So
Mm-hmm.
that makes it three centered, four electron bond. Okay.
Right.
Hmm. Why four electron beta? Unlike hydrogen, earlier hydrogen didn't had any electron, but fluorine has extra lone pairs, right? So it will
Right.
support a lone pair here, and here it will make a normal bonding. So now what
Right.
happens is this three together is making a bond in which four electrons are moving like this. So it is forming a banana bond, but how many electrons this time? Four electrons.
Four.
Okay.
Four electrons.
So this is a three centered four electron bond.
3C4E.
Hmm. Okay.
Hmm.
Next, Al thrice also exists as a dimer form like this Al2 Me6. Hmm? So you can
Right.
see बट मिथाइल के पास कोई लोन पेयर नहीं है, सो इट इज जस्ट लाइक अर्लियर हाइड्रोजन की तरह। ओके, सो सिंगल सिंगल इलेक्ट्रॉन्स ओनली, सो हियर यू विल हैव थ्री सेंटर टू इलेक्ट्रॉन bonds.
Right.
Now dimerization depends upon how bulky this group is. If it is becoming very bulky, dimer is not possible. That's why rate of
Okay.
dimerization decreases as the bulkiness increases.
Sir.
Hmm.
Slow, sir. Overload, sir. Slow.
Yeah, sorry. Once come to that point directly. See, double salts which lose their identity on adding to water, that is called, I mean, in fact, they lose their identity. That's why they are called as double salts. We have come across this definition before in coordination compounds. Yeah.
Yeah.
Alum is one of the double salts here. Okay. So you can see uh, the general formula of alum is this one: metal connected with water with 6 moles here, and another metal which is of +3 oxidation state connected with 6 moles of water. Okay.
Right.
So now this is 2 moles of this and 1 mole of this. If we combine with some sulfate and H2O outside as the crystallization, water of crystallization, this entire thing will be observed as double salt, alum. This entire thing is observed as alum. See, the one which is the metal which are of +1 oxidation state, that could be sodium, potassium, rubidium, cesium, and thallium. Okay. Generally, lithium does not make complexes. Okay. Ammonium can make. Okay. So
Hmm.
ammonium is like a pseudo form of that alum. But yes, these are the ones which can make. At the same time, metal +3 will be aluminum, chromium, iron. These are the ones. Okay, cobalt also in some case. So they should be usually trivalent cations. Clear?
Hmm.
Now both potash alum, right? If you notice, it will have potassium and aluminum form. Chrome alum, you will have chromium and potassium. Ferric alum, iron and potassium. So these are called respective potash, chrome, and ferric alums. Clear?
Hmm.
Pseudoalums. Pseudoalums as in instead of +1 oxidation state, now you have +2 oxidation state. Okay.
Okay.
So if you have +2 oxidation state and +2 with H2O6 and +3 with H2O6, if they are combined with SO4 4 times and 6H2O, then this is the product you will have. Like FeSO4, Fe2SO4 thrice, and 24H2O.
Okay.
And same way, instead of iron, you can have manganese here, and you can have this is the pseudoalum form. Done?
Yes, sir.
Hmm. Now, usually alums are prepared by taking concentrated salts and crystallizing with sufficient water.
So,
Okay.
yes, sir.
Hmm. Hmm. See, alums are used
Hmm.
in purification of water, clotting of blood, and mordant in dye industry. Okay.
Right.
Hmm. And see, last thing is about what are the reactions of Al2O3. Al2O3 is an amphoteric oxide beta. So when you react with acid, it will react as a base and it will become AlCl3 and H2O.
Hmm.
Okay. But when you react with NaOH, it will act like an acid, converts into this AlOH thrice first, and with further NaOH converts into soluble NaAlO2,
Right.
sodium beta aluminate, like a salt form. Hmm? And then
Right.
Al2O3 plus carbon plus N2, this will convert Al2O3 into AlN, carbon monoxide will form. Same way with carbon and X2, it will form AlX3 and carbon monoxide. Even with excess of carbon, it will become aluminum carbide and carbon monoxide.
Hmm. Right.
That's it. These are the typical reactions observed in boron. Okay. So
Yes, sir.
if you check out the boron family, this is how much you need to know. Hmm?